So we do have 6 total trig derivatives. I'm going to introduce to you just sine and cosine today, and then we're going to practice how to do a tangent line and a normal line. So the process is the same. Process we learned before, that every tangent line needs one point and one slope. We're going to do the same thing. We're just going to do it with a trig function instead of a polynomial function. A couple trig things I need you to remember in order for this all to make sense to you. When I taught this, I would teach it with a funny little cheer. I don't know, I think you guys still learn the cheer in Ham. It goes sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. All right, this is not calculus. This is a trig identity. What that means is like this. So it goes sine, cosine, cosine, sine, cosine, cosine, sine, sine. And the last sign, when you say sine, 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 there's always like an extra one. It's like, what is the purpose of that extra little? It's a sign change, which means I go back and I change the middle to the opposite of what it was. So when I write it, I do it like this, and I change my plus minus to a minus plus. Okay, but then the letters have to go into this problem as well, and so they just go in alphabetical order. So you need sine A, cos B, and cos A, sine B. You never change the order of the letters. A comes first always, B comes second, and then same thing in the other one. A first, B second, A and B. All right, so I just wanted to refresh your memory on that. You'll need that quick a minute. So that's what you need from Ham. This is what you need from calculus. We learned that sine has a special limit. Okay, we learned this shape and that it always has the same answer no matter what. If A approaches 0, then what does the limit approach? 1. Okay. We get that by, if you can remember, what the graph looks like. The graph of that particular function starts up here and then loses steam. So that's the graph. So it always starts at that value, which is why the limit above 0 is 1. Okay, the next limit we have not learned yet, but I'm going to teach you what it is. Okay, the limit of this one is 0, and you're just going to have to believe me that that is the limit of that. I'll prove it to you after you actually know this lesson, that I'd be able to prove it to you. Okay. All right. Do sine and cosine occur in physics? Yeah. Can you give me an example of a physics lab you've done that involved sine and cosine?
Vectors.
Vectors do. Yeah. Did you guys ever do the weight, the mass on a spring, like bobbing up and down and observing its motion? You guys still do that? Okay. Newton needed sine and cosine, so he had to figure out how it was going to go. Okay, because Newton was doing physics, so he needed to figure out how to prove it. All right, so here's what we're going to do. We're going to tackle this with Newton's proof. So you got to remember how Newton set things up. Newton said the limit, and then of sine of, and then he had x plus h minus the sine of x all over h. And what did h always approach? 0. That was how Newton set it up. So he was bound and determined to figure out how to work this out. What would be the problem of plugging in 0 right now? Yeah, why? What would you get if you put 0 in for both positions of h? You'd get sine of what? Sine of x minus sine of x over 0. And the problem is 0 over 0. And what did we call that? Indeterminate. All right, so Newton's like, well, bummer on that. I got to go back and figure this out. So you have to go back to your trig identities. So he needed to apply the cheer. And the cheer would go to this because it was an addition. So he's got to do sine, cosine, cosine, sine on that particular section of it. So he set up sine, cosine, cosine, sine. Okay, so what goes in the first sine? X. What goes in the next cosine? H. Okay, then plus, sorry, I ran out of room. Then the next cosine is X and sine of H. Then there's still the minus sine of X all over H. Okay, are you guys with me so far? All right. Okay, then we need common denominators on all these things. So we're going to have the sine of X times the cos of H all over H, plus the cosine of X times the sine of H all over H, minus the sine of X times all over H. So everything gets to be over H. Okay, this is called common denominators. Okay, then we change just the order. Then we change the second two terms, the third and the second and the third term. So flip-flop and make the sine of X over H the second term, and then the cosine of X times the sine of H over H. There we go. That's the order that you want everything in. All right, now I want you to take a good look at this, just those two, and see if you can do any kind of group factoring. Okay, is there anything that has in common? Sine of X, okay? It has the sine of X in common. So Newton noticed that, okay? And so we've seen where factoring comes into play here. So I'm out of room. Maybe you guys can shrink yours down a little bit. So I'm going to slide mine over. So we've got the sine of X factored out from the cosine of H minus 1, and that was all over H. And then you had the other one at the end, okay, plus. And then let's distribute our limit so that we're writing it in good form, times the sine of H all over H. All right, now we're in the home stretch. Okay, here is this relationship that we really like, sine of H over H, in combination with this limit that we really like. What did we just say the value when H approaches 0 is of sine of H over H? We just said that that was 1. Here's the other one that I told you about. Here's this really nice combination, cosine of H over minus 1 over H, combined with this limit. And what did I tell you that was equal to? 0. So if that term is equal to 0 and the other term is equal to 1, what are we left with? Careful, what are we left with? I mean, what happens to this 0 when you combine it with that? That's 0, okay, so that's the whole thing is gone. And what are we left with? Cosine of X. That's it, after all that. And so what did Newton discover? What was he trying to prove? The derivative. The derivative of sine is, it sure is. The derivative of sine is cosine. What do you think the derivative of cosine is? I wish. The derivative is negative sine. All right, your proof for that is in your homework. You're going to work that out in almost the same way I just worked this out. Try and follow it. Do the cheer. Only your cheer is going to be the cosine, cosine, sine, sine, sine part of the cheer. All right? See if you can figure out what Newton figured out. That's part of your homework. All right? The derivative of sine is cosine. The derivative of cosine is negative sine. I need you to walk out of here knowing those two things. Spoiler alert. Any trig function that starts with the prefix co, what are the other ones besides cosine? Cotangent, cosecant. All of them have negative derivatives. Anything that starts with a co has a negative derivative. All right, so let's try it. Find the normal line. Okay, stop. Before you even process anything else, what does your brain tell you when you need to find a normal line? I need a point and I need a slope. Right. Okay, so that's what we're going to do first. We're going to need a point. We are going to need a derivative, and the derivative is going to help me find a slope. So those are the things I need so that I can do this. My point is going to be pi, comma, and then 3 times the sine of pi. What is 3 times the sine of pi if I plug pi in? We got to be quick on our derivatives here. Okay, we're going wave. Okay, what is it? It's 0. Okay, you're going to have to, like that wave for sine, you got to know, okay, I hit at pi. All right, my derivative. Okay, what is the derivative of 3 sine x? Well, we know that 3 is a coefficient, so 3 is just 3. It just stays there because it's a coefficient when the derivative of sine x is cosine x. So the slope is going to be 3 times whatever the cosine of pi is. Okay, so now I got, well, shoot, what's the cosine of pi? So either you're doing a wheel in your head, a unit circle in your head, or you're doing a wave in your head, but somehow you got to come up with the cosine of pi. What is the cosine of pi? -1. So this is 3 times -1, so -3. So now I have my point and my slope, and I can write my normal line. And so my normal line in the right format is y minus 0 for the point. The normal slope of positive 1/3, instead of -3, it's positive 1/3, and x minus pi. That's my normal line. See, once you know the derivative of sine is cosine, you can do any of the stuff we've done before. Okay, next one. Find the derivative of this. Oh, okay, well, every rule we had before still applies. What rule are we going to need? We are going to need the quotient rule. We're just going to use trig in the quotient rule while we're doing it. So we're going to have y prime will be, all right, and then you just fill in the gaps for your quotient rule. Okay, so what goes first? Cosine x minus 2. And what goes second? Okay, we're looking for the derivative of the top. And the derivative of the top is cosine x. Okay, minus sine of x. And then times the derivative of the bottom. I heard it. Negative sine of x. Is it minus 2? What is it? What's the derivative of minus 2? 0. So, okay. And then the denominator is going to be cosine of x minus 2. Okay, then I clean it up by doing a little distributing here. So I'm going to distribute, and I'm going to distribute. So what's cosine times cosine? Cosine squared. And then minus 2 cosine x. And then the last chunk, when I multiply those two together, what do I get? Positive or negative? Positive sine squared. Then I put it in the right order. Sine squared comes first. Cosine squared comes second. Minus 2 cos x comes at the end. All right. you might get this far and you might check the answer in the back of the book, and the answer in the back of the book looks different. Or, not in the back of the book, on the PDF that I've given you. See anything else about that?
Sine squared plus cosine squared is 1.
Yeah, but do you remember what you call that? It has a name.
It does?
It's called the Pythagorean identity. No, but sine squared plus cosine squared is always 1. This term is always, now does that work for sine squared minus cosine squared? No, only for sine squared of x plus cosine squared of x. So that's equal to 1. So my numerator is 1 minus 2 cos x. My denominator is cos x minus 2 squared. And that's as far as you can take that. You can't take it any farther. Okay. All right. Find the equation of a tangent line to x cos x at 1. Okay. So we need a point. We need a derivative. And we need a slope. Can I have a volunteer to give me a point? Get me the point. Okay, Andre. 1, comma. All right, and then what are you doing with that 1?
Plug it into both x's.
Okay, and so when you plug it into both x's, oops, what do you get?
1 times cosine of 1.
Right, 1 times the cosine of 1.
Isn't that just 1?
The cosine of 1 is not 1. It's the cosine of 1. That doesn't have a nice number. It's not like the cosine of pi. Cosine of pi has a nice number. The cosine of 0 has a nice number. The cosine of 1 does not have a nice number. Try it in your calculator. It's in a horrible decimal. Okay? And that's okay. We just leave it the cosine of 1. All right. The derivative. What rule do we need to find this derivative? How are x and cosine of x related to each other? Yeah, what do we understand is between them? A multiplication symbol. We understand that this is x times cosine x, and because it is multiplication, we are going to need a product rule. And so we will need a product rule to find the derivative. So I will start with cosine of x, and then I will have the derivative of x, which is 1. And then I will have x, and then I will have the derivative of cosine of x, which is negative sine of x. So my slope will be what I plug 1 into that. So I end up with cosine of 1 minus sine of 1. Okay, now would you make sure your calculator's in radian mode, and when somebody type those in to get me a number? I'd like a number for the point. If somebody could just give me regular cosine of 1, I'd appreciate that. And then if somebody could get me the slope, that would be great.
Regular cosine is
0.540. Okay, how about cosine 1 minus sine 1? Should be a 0 point something number also. Anybody got that? Okay, Sean?
Negative 0.3.
Oh, a negative? Sorry. Negative, say it again.
Negative 0.3011.
Okay, right, so then we want to write our tangent line. And so our tangent line then would be in the form y minus 0.540 equals negative 0.301 times x minus 1. Always go to 3 decimals. That's our agreement. We made that agreement earlier. At least 3, if not more. 3 would be the minimum. Okay, here's what that looks like. Here's the point that they have in common. And then there's the tangent line that skims across, touching that at that one point. Okay, there's the tangent line. So I just thought you might like to see what it looks like. Okay, I did allude to this physics experiment. I'll have to check with Mr. Edlin when he's planning to do this with you. But if you have a spring, like a slinky or a spring, and you put some kind of mass on the bottom and you pull on it and let go, then that thing is going to bob up and down indefinitely. This is different than a yo-yo. Okay, if you have a yo-yo on a string and you let the yo-yo down, it will come maybe up and down for a little bit, but it's going to stop eventually. A spring will stay in motion indefinitely. It will never stop bobbing unless you physically stop it. Okay, nothing will ever stop that spring from bobbing. Okay, so draw yourself an example of a spring with a mass on the bottom. This mass, this motion of up, down, up, down, up, down can be modeled with a sine or cosine function. So we can measure the velocity of how it's going up and down and up and down and up and down using our calculus. So if the motion is 3 sine t, then we should be able to figure out the velocity and the acceleration. Okay, if 3 sine t is the velocity, then 3 cos t is the, if 3 sine t is the position of the spring, then 3 cos t is the velocity of the spring. And the acceleration would be 3 times negative sine of t, or we would say negative 3 sine t. Our units are just as important. The velocity would have units of meters per second, and acceleration is also measured in meters, but the seconds are seconds squared when you get to velocity. So you're going to do the exact same thing you did previously to answer the following question. Is the spring speeding up or slowing down at 3 seconds? You need to compare, in order to answer speeding up and slowing down, what 2 things do you have to check?
Velocity.
Yes, you have to check velocity and you have to check acceleration. If they match signs, then it would be speeding up. If they have different signs, it would be slowing down. So you will need to find v of 3. You will need to find a of 3. You can use your calculator to do that. And then you want to compare the values. Okay? Whether they match sign or not will be able to help you to answer that question. All right.